Hello learners, welcome to another practical physics class. My name is Byekwaso Semakula Samuel. I'm a teacher of physics. In this class, we shall demonstrate an experiment to verify Hooke's law. Hooke's law states that the extension in an elastic material is directly proportional to the force or tension in that elastic material, provided the elastic limit is not exceeded. So in this experiment, we are going to use this spiral spring as our elastic material. An elastic material gets deformed when a force is applied, but when the force is removed, it regains its original size and shape. We are going to use this meter rule to measure the extension. We shall use a pointer, okay, and then we shall use these masses, standard masses. For each mass, we shall find the extension, and then we shall be getting that ratio, the ratio of the weight to the extension. According to Hooke's law, that ratio should be constant. So we have our spiral spring, which we have clamped next to a meter rule, which is standing vertically. We have a pointer, which will help us get the position as the spring extends, and from that position of the pointer we shall be able to get the extension. So the initial pointer reading, we can look at it. Initial pointer reading is 54.8 centimeters. So the initial pointer reading, which we can call P0, is 54.8 centimeters. So we have a table here. The masses, we are going to use three masses, mass of 0.1, 0.2 and 0.3 kilograms. The weight, as we can see, is 1, 2 and 3 newtons. For each of these masses, we shall get the new pointer reading. And for each of them, we shall calculate the extension, which is the difference between the new pointer reading and the initial reading. And then we shall get the ratio of the weight to the extension. So the initial pointer reading, which we can call P0, is 54.8 centimeters. So we have a table here. The masses, we are going to use three masses, mass of 0.1, 0.2 and 0.3 kilograms. The weight, as we can see, is 1, 2 and 3 newtons. For each of these masses, we shall get the new pointer reading. And for each of them, we shall calculate the extension, which is the difference between the new pointer reading and the initial reading. And then we shall get the ratio of the weight to the extension. So we are loading the mass of 1 newton, and when we load that mass, we shall be able to get the new pointer reading. The new pointer reading, when we have a weight of 1 newton, is 59.2 centimeters. Then add another mass so that we have the total weight of 2 newtons. So when we add the 1 newton weight so that we have a total weight of 2 newtons. The new pointer reading now moves to 63.3 centimeters. Lastly, we add another mass to make it 3 newtons. And when we add that, the new pointer reading now moves to 67.4 centimeters. We now record the new pointer readings for each of the weights. For the 1 Newton weight, we had a pointer reading of 59.2. Then for the 2 Newton weight, we had 63.3, and for the 3 Newton weight, we had 67.4. 4.4.
Poco sporingi coglione. Springi magari scuola sporingi.
We then calculate the extension. Extension is new pointer reading minus the initial pointer reading. So 59.2 minus 54.8 give us 4.4. 63.3 minus 54.8 gives us 8.5. And then 67.4 minus 54.8, we get 12.6 centimeters. Next, we get the ratio of the weight to the extension. 1 divided by 4.4 gives you 0.23 to 2 decimal places. 2 divided by 8.5 gives 0.24 to 2 decimal places. 3 divided by 12.6 is 0.24 to 2 decimal places. So from this, we can conclude that the weight divided by the extension is equal to a constant. A good approximation is equal to a constant. So if the weight over the extension is equal to a constant, it implies that the weight is directly proportional to the extension, and this is what Hooke's law tells us, that the force, in this case the weight is the force exerted on the elastic material, is directly proportional to the extension.